been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, this is the first part of chapter 6 that we're going to talk about, and we're going to learn about similar figures in this video. Similar figures are figures that have congruent corresponding angles and proportional corresponding sides. So if you remember back to when we were talking about triangle congruence, and we might say that triangle ABC is congruent to triangle XYZ. And remember we said that A corresponded to X, and then B corresponded to Y, and C to Z. So when I talk about corresponding angles or sides, that's what I'm referring to, the corresponding parts. Before we can actually talk about similar figures, we need to make sure we know how to solve a proportion. Proportion is basically just an equivalent ratio. So my first example is 3/5 equals x over 8. And so when it's not obvious, like how do I get from 5 to 8 by multiplying? Well, that's not quite obvious. If that number was a 10, then I would know it's times 2, but it's not. And so in equivalent ratios like this, the cross products are equal. So this is how I'm going to set up my equation. 3 times 8 equals 5x. 8 times 3 is 24 equals 5x. Divide by 5. X equals 24 over 5, which cannot be simplified because 5 doesn't go into 24 and 5 is prime. So I could just write it as 24 over 5. I could also figure out what that is. 5 goes into 24 4 times with 4 left over, so that is the same as 4 and 4/5. 4/5 is 8/10, so that would be 4.8. So in this example, x is 4.8. Looking at the next example, 2 over y equals 5 over 7. So again, our cross products are equal. 7 times 2 equals 5y. 14 equals 5y. Divide by 5. Y equals 14 over 5. 5 goes into 14 2 times with 4 left over. So that's 2 and 4/5. And that is 2.8. So y equals 2.8. All right, so here's an actual example of similar figures. So the statement here says that triangle ABC is similar to triangle DEF. So you need to make sure you know what this symbol means. That means similar to. And so if they're similar, then what do we know? We know that they have congruent corresponding angles and proportional corresponding sides. So A corresponds with D, so those angles are congruent. B corresponds with E, so those angles are congruent, and C with F. And then the sides are proportional. So angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Those are corresponding angles. And then the corresponding sides are going to be AB corresponds with DE, and then BC corresponds with EF, and then CA or AC, it's the same thing, corresponds with FD. So those are your corresponding sides, and as you can see, all of those ratios are equivalent, and if they're not, then they're not similar figures. So I compared the first triangle, triangle ABC, to triangle DEF. So triangle ABC is always on the top, triangle DEF is always on the bottom. That doesn't necessarily have to be the case, but you've got to have consistency. If all the numbers on the top don't come from the same triangle, then there's a problem. So now we're going to actually solve a problem here. So it says AB is 30, BC is 25, DE is 18, and we need to find EF. So I'm going to go ahead and label this. AB is 30, BC is 25, DE is 18. I will caution you that similar figures are not always drawn to look like each other. Sometimes one is twisted around or turned around. So make sure you know what parts correspond. This one is pretty obvious. So I'm going to compare the AB to the DE. So that's going to be my first ratio. 30 over 18 equals. Now, what do I know? I know the 25. And does that go with the 30 or the 18? It goes with the 30 because it comes from the same triangle. And I'm trying to find EF. Well, does EF correspond to the 25? Yes, it does. So I'm going to call that X. And now I'm going to solve my proportion. So 18 times 25 equals 30x. So 18 times 25 is 450 equals 30x. Divide by 30 on both sides. So that equals 15. X equals 15, which x is my EF, so EF is 15. Remember that EF means the distance from E to F. You do not have to have a segment there to necessarily find the distance. I know that confuses y'all sometimes. So EF would be 15. Now we need to determine if the following figures are similar, and if so, we're going to determine the scale factor. Scale factor is the ratio of the lengths of corresponding sides. So if figures are similar, then what do we know? We have congruent angles and we have proportional corresponding sides. So we don't have any angle measures here. So we need to check the ratio of the lengths of the sides. And so in this example, we have quadrilateral ABCD, and we're trying to check if it is similar to quadrilateral QRST. And so what we're going to do is we're going to write the ratios and see if they're equivalent. So AD with the 10 should correspond to QT, which is 5. Then AB should correspond to QR, which is 6. BC should correspond to RS. And lastly, DC corresponding to TS. And so if I simplify all of these ratios, I get 2, 2, 2, and 2, or 2 over 1. So all of those ratios are equivalent. Therefore, yes, these are similar figures. And now it's asking, what is the scale factor? The scale factor is the factor by which the figure was dilated, meaning either made bigger or made smaller by a multiplying factor. And so obviously ABCD is larger than QRST. And so the factor from the small to the big is 2. So ABCD is 2 times larger than QRST. And so you could write that scale factor as 2 or 2 over 1. And you just have to be real careful that you pay attention to which one is the larger figure. Okay, and so this 2 corresponds to ABCD because it is the larger. So if your scale factor is 3/4, then this would be the larger that it would correspond to.
I've been waiting way too long.